Okay, so I think most people have arrived. We will be recording today's webinar anyway, so if your connection drops or you're unable to stay to the end, you will be sent a recording afterwards so that you can catch up on the things that we have covered today. So thank you for joining today's webinar on empowering communities through citizen science and the role of analytical chemistry in sustainable solutions. So whether through public health or environmental initiatives, citizen science and involving the public is an important area for analytical scientists. And this can come in a variety of forms, whether that's monitoring environmental changes, data collection and analysis, product development for use by the general public, or engagement and education initiatives. There are a number of ways that communities can be involved in searching for sustainable solutions. Over the course of today's webinar, we're going to be discussing what this means for analytical scientists and how further study might give you a competitive edge in addressing real-world problems. So today I am joined by a panel from our Analytical Chemistry and a Measurement Science programme, and we are going to begin today by introducing ourselves, and after that we'll begin our panel discussion on the role of analytical chemistry in sustainable solutions and how that fits in with citizen science. After that, we're going to come to your questions, and this can be submitted at any time during today's webinar, and you're able to do that using the Q&A function in Zoom. And then finally, at the end of today's session, I will also give a very brief course overview. So I'm now going to introduce myself and hand over to our panel to introduce themselves too. So for those of you who've not met me before, I'm Hazel and I am the course advisor here at the University of Manchester, and I'm here to support prospective students, ensuring that they have the information that they need to make an informed decision about choosing to study with us here in Manchester. And that can be through events such as today, and it's great to see so many of you here, but it can also be through things like emails or through one-to-one phone calls or consultations via Zoom or Teams. And I will share my contact details at the end of today's webinar as well if you do have more questions and want to discuss the course in more detail. I'm now going to hand over to Rashila to introduce herself.
Thank you, Hazel. Hi, everybody, and welcome to our webinar. I'm Dr. Rashila Mudli, the course director for the MSc in Analytical Chemistry and Measurement Science at the University of Manchester. This program is part of the Faculty of Science and Engineering, as well as part of transnational education. Welcome again to our webinar. Thank you.
Hi, I'm Brandolyn Reitnauer. I am an analytical chemist for general ecology, and I am a student at the University of Manchester.
Hi, everyone. Thank you for inviting us to participate in this webinar and for highlighting such an important topic. I am a chemist by profession. I started analytical chemistry laboratories at the National University of Costa Rica, focusing on environmental monitoring. I currently work at Incienza, which is a public health institution, where I lead the food safety division within the bromatology laboratory. Our work involves regulatory verification of different products, including rice, corn, dairy, or peanuts, as well as other products of interest like alcoholic beverages, cigarettes, vapes, and hemp products, where the last one is my most recent addition, which I explored during my master's studies at the MIB of the University of Manchester. In our division, we applied advanced analytical techniques to detect emerging contaminants, integrating research to support public policies based on evidence. I'm happy to be here and to share my experiences over the years in applying analytical chemistry to understand what is going on with the products we consume and improve our quality of life. Thank you all.
That's brilliant. Thank you very much, everyone, for introducing yourselves. And I should have said as well to everyone watching as well, if you want to introduce yourselves and say hi, then you can also use the chat function today to do so. So I am going to move on to our first question, which is how can citizen science initiatives contribute to solving sustainability challenges in areas such as environmental monitoring or public health? I'm going to come to Rashila first for that one.
Thank you, Hazel. Firstly, let me define citizen science for everybody. And so I've thought about this and put together quite a nice definition, I think. So citizen science, also commonly known as community science, refers to the voluntary participation of non-professional scientists, or basically community members, in the monitoring, collection, and analysis of scientific data. And this is done in collaboration with scientists or researchers. This kind of collaboration fosters a bidirectional flow of information. That means from the community to the scientists and vice versa, advancing scientific research while empowering communities. In essence, citizen science democratizes analytical science by putting the tools of measurement and inquiry into the hands of the public, allowing science to be done with the people, not just for the people. So coming now to your question, Hazel, how can citizen science initiatives contribute to solving sustainability challenges? Firstly, the key here is in finding sustainable solutions to global challenges. And the best way to do this is to capitalize on the synergies between the knowledge of the communities and modern scientific methods. For example, in environmental monitoring, and most of us in analytical science are involved in environmental monitoring, one of the major environmental challenges in India is the pollution of the Ganges River, or the River Ganga, as they know. By integrating indigenous knowledge systems and culturally rooted practices that have been passed down from generation to generation with contemporary analytical methods, we can find sustainable solutions. Examples will include the traditional use of sedimentation ponds for water purification, or harnessing the local biodiversity for phytoremediation, such as the use of water hyacinths for the removal of nutrients and toxic metals from water, with modern instrumentation techniques such as chromatography and spectroscopy that we teach in our course. So this kind of harmonization ensures scientific validation while being culturally resonant, which gains the trust of the local communities and then collectively resolves these global challenges. So it's about basically working together, scientists and communities working together to find sustainable solutions.
Brilliant, thank you. And Andrea, was there anything you wanted to add?
Well, I think Dr. Motley pointed out very well. Where citizen science projects is to empower individuals and communities to actively engage in data collection. We have to emphasize that the voice of the public plays a vital role in the scientific process. I think the point is, if we generate communities with public engagement, we can gather larger data sets that would otherwise be difficult to obtain. So we have to involve communities in this process. In environmental monitoring, for example, citizen science can help us in data collection at scale, where volunteers can gather extensive environmental data, as I said, through biodiversity observations, deforestation complaints, or pollution alerts. In terms of public health, reporting certain products, like in our case in Incienza, help us track contaminated products more efficiently. Engaging in public and scientific research raises public awareness and the integral responsibility that health actually is, and pressures, if we can say that, institutions or industries to adopt more sustainable practices. Thank you.
And Brandolin?
Yeah, so mainly when the general public is concerned, I noticed that here in the US we have some EPA guidelines. So it's mainly when there's an issue that's, like, for example, PFAS is one of our main concerns at the moment. And I know that when we are like hearing about it in the news, I feel like the EPA will start taking in information and then providing guidelines. So that's something that the general public is starting to become more concerned about. And now like there's an additional step that needs to be taken.
That's brilliant. Thank you, everyone. So we're going to move on to our next question, which is, what are the most significant sustainability challenges that analytical chemistry can help address? And I'm going to go to Andrea first this time.
Thank you, Hazel. That is a great question. Actually, analytical chemistry provides precise methods for detecting, for quantifying, and that help us to mitigating environmental or health-related issues. In environmental pollution, for example, here in Costa Rica, as we become more and more dependent of private transportation, our cars, air quality monitoring becomes essential to control and reduce contamination levels. So analytical techniques such as GCMS help to detect pollutants like volatile organic compounds or greenhouse gases, enabling regulatory action and mitigation strategies as well. In food safety, techniques for heavy metals are employed, like ICP-MS or absorption spectrometry. And for organic contaminants, since matrices are more complex than air or water, it requires stronger extractions, employing analytical chemistry as well, and more sensitive analytical techniques such as HPLC-MS that helps to verify these contaminants or verify mislabeling. I always say that analytical chemistry will always help us facing these challenges, because if you have a problem, most of them will include an analytical chemistry route toward a solution, because what we can measure, we can improve it. So analytical chemistry is always present to facing these challenges.
Thank you. And Brandolin?
Yeah, so I agree with Andrea. I think that analytical chemistry will definitely help guide information as far as what you're looking for and help reduce or maintain certain things. But more addition to that is the challenges that we face or the detection limits that we would see on some of these contaminants. So I know some instruments can get down to parts per trillion. Sometimes it's parts per billion or even higher. So the sensitivity of the instruments is definitely a challenge, and making sure that you're not contaminating a sample as far as like something in the environment that would be kind of floating in the air. Like we have different types of contaminants that could potentially impact our results. So getting the right information is definitely a challenge.
Brilliant, thank you. And Rashila, was there anything else you wanted to add?
I think Brandolin and Andrea have covered it, but just to say that analytical chemistry is a central science. So any type of analysis that requires instrumental methods, then analytical science is important for those kinds of analyses.
That's brilliant, thank you. So we'll move on to our next question, which is, how can analytical scientists work with the local communities to collect and analyse data that can drive change? And we'll come to Brandolin first for this one.
Okay, so for example, in general ecology, we are a water filter company, and the public has mentioned that they were interested in PFAS reduction, mainly for the health of themselves. So what we've done is taken some of the analytical equipment. So in this case, we would use LCMS in order to determine whether our filters are reducing the PFAS in the water. So in this case, where we have to send out because we don't have it on site. But one of the nice things about Manchester is they challenge us to find an instrument that we could present on to basically convince our company to buy it. So it was nice that Manchester gave us the opportunity so we could look into something that we don't have. But if we did have it and we did test for it, we know that we are testing for the PFAS reduction, and we do follow in that means. So it was nice to know that like the community is saying like, we're worried about this, and we ourselves are doing things to test against it.
That's great, thank you. Rashila, I'm going to come to you next. Oh, you're still muted.
So I will just speak generally about this analytical science and citizen science and in answering this question. So when pollution is suspected, the best outcomes are produced when scientists and communities work together to resolve the problem locally. And we've seen that in many examples. Even COVID has shown us that as well. And for that to work, communities need access to modern citizen science tools. And now, with the advancements in research, these tools are readily available. But with the tools, there must also come some basic training because the local person and lay person doesn't know how to use these instruments. So they need to be trained on the use of these instruments so that they can proactively take direct measurements of pollutants in their environments. So once you suspect that there's some kind of contamination, you need to empower these communities by providing the tools, the training, so that they themselves can do the actual data collection. And this kind of collaboration can help prevent serious health issues like birth defects and cancers that are often linked to high levels of contamination, for example. And I can cite an example. So one of the very powerful examples is the Love Canal disaster in New York. That happened in the late 1970s. But of course, the contamination started earlier on, but was picked up later on in the 1970s. So residents later found out that their neighborhood had been built on a toxic chemical waste site. And here in this community, more than 33% of the population suffered chromosomal damage and birth defects. And these birth defects were really quite alarmingly common. And it kind of indicated that there was a problem in the environment or the ecosystem. If their concerns had been taken seriously from the start, and if citizen science tools for monitoring had been available at that stage, it's likely the damage could have been mitigated much earlier. So, to answer your question, how can analytical science work with local communities? They can provide the tools, and then collaboratively, they can work to change the environment, identify the problems within the environment, and so on.
That's brilliant. Thank you. And Andrea, is there anything you wanted to add as well?
Well, I just want to add that, in fact, scientists should work with communities. This creates mutual benefits. This builds trust. And for example, if we co-design research with local participants, that helps to understand local concerns, and they feel the study more relevant or more impactful or responsive to real community challenges. And for the tools, or how can we work with them, maybe public forums, or now with technology, we have an important tool that we can take advantage of. For example, create user-friendly mobile apps, accessible platforms, or AI tools for data submission that they can use, and that maybe simplify the report findings and help us to our study.
That's brilliant. Thank you. So our next question, I'm going to draw more on thinking about our analytical chemistry and measurement science course. So I'm going to start with Rashila, and I'm going to ask, what skills and tools do students gain from the course that helps prepare them for involvement in citizen science initiatives?
We give our students a solid grounding in scientific rigor, which makes them well prepared, not just to take part in citizen science projects, but also to lead these projects, to work with the communities to come up with research questions and ideas on how to resolve these challenges within their communities. They build a strong our students build a strong understanding of core techniques like spectroscopy, chromatography, mass spectrometry, and elemental analysis. So they are able to validate and interpret the data that is collected by the communities and even help out with field sampling and analysis. So researchers, or our students, once they become researchers and fully fledged scientists, can go into the communities and train the people in these communities and help them to do the sampling and analysis in the field. Our chemometrics unit as well also trains our students in statistical analysis, which is key when working with large, often messy data sets that come from citizen science work. And throughout our course, students engage with real-world case studies, as Brandolyn will attest to, because she's just recently done the course, from tracking environmental pollution to public health issues. So they learn how to connect lab results with the bigger picture. So that kind of thinking aligns perfectly with the sustainability and community-driven goals at the heart of citizen science.
That's brilliant, thank you. So, Brandolyn, as Rashila's just kind of referred to you, do you want to sort of share your thoughts on this?
Yeah, sure. So, yes, Rashila's right. I did just finish the course where I was working on that. And it is interesting. I remember reading this report to my mom, and she was like, wow, I didn't actually think of like plants in that aspect. So, like sharing that information with people who are not necessarily like thinking along the lines of like how we do, it was nice to know that like it is impactful and it is something that could be more like readily shared because analytical chemistry can definitely help provide great information that you can't just get as a normal like citizen. So combining those, but it is nice, like she said, we were also like learning about mass spec and a lot of the things in analytical chemistry. There's so many different avenues that you can go as far as pharmaceuticals, environmental, water quality. Like basically, if you think of any type of product, at the end of the day, it's always going to be some type of analytical testing that's involved with it.
That's brilliant. And Andrea, how about your experience?
Yeah, I agree with those statements. This program has been very important for all the knowledge I've gained. Because in terms of public health, when a community problem arises, it is essential for us to have the knowledge of different analytical techniques to select objectively which fits better for our desired purpose. Also, I have improved my research skills as well, because it provides me with critical thinking to design experiments more accurately. And thanks to my professors and supervisors, I could update to the top technologies available in the market that I haven't been exposed to during my career.
Oh, I think she's frozen just there. So what we'll do is, if she comes back online in a second, then we'll come back to it. But I think we've probably got time for one more question before we move on to our question and answer from audiences. So if in the audience you do have questions that you want to ask our panel today, then you can do so by using the Q&A function or the chat. And so please do submit anything that you would like to ask, and we'll come to those shortly. So what I will do is I will move on to our next. Oh, Andrea, you're back.
So I'm sorry.
That's all right. I'll let
So
you.
I was saying.
Carry on.
Just to finish, chemometrics has helped me to manage a large amount of data or improve data interpretation. Sorry about that.
No, that's not a problem at all. So I was just saying, I'm not sure if you heard and if anyone else has changed, because we've just seen the numbers change on our attendees as well. We're going to come to one more sort of preset question, and then we'll move on to audience questions if anybody has anything that they wanted to ask. So the last question I'm going to choose from our list is just thinking about your own experiences. And I'm going to ask you to share some examples of how you have contributed to sustainability or citizen science initiatives, and thinking about that kind of within your own work as well. So Brandolyn, I would like to come to you first, if that's okay.
Okay. Yeah, as I mentioned, the PFAS is definitely one of those issues that is well known. And again, like I said, we we are testing to that standard and trying to limit that. I'm trying to gear everything more towards the way that we work in the water filter industry. So I know there's a couple other contaminants that we're looking for, but at the moment, the EPA regulations are one of our most important for the PFAS. So mainly just sticking with that one.
That's great. And Andrea?
Sure. As an example, in water monitoring project, I remember we implemented a system to assess drinkable water quality and calculate the distribution of disinfectant, specifically hypochlorite ions, in drinkable water supply, serving a community of over 100 homes. And the core of our study was determining the optimal amount of hypochlorite we have to add to the source tank, enough to ensure effective bacterial control at the farthest point in the distribution network without exceeding safe concentration levels at the initial homes. We engage community leaders in a public forum to help identify the most informative sampling points. We receive information about where the analyte might degrade or be lost, like to shape the direction of the study. And when it was time to collect samples from homes, I remember residents were more receptive and willing to participate in our study. And actually that engaged the community with the laboratory as residents became more proactive. They called us at the laboratory for questions and they were able to report irregularities and so on.
That's brilliant, thank you. And Rashila, over to you as well. And perhaps if you are aware of any examples of other students from the course as well that you can bring in, that would be great.
Okay, so let me just start with something that I worked on in 2020. So I led a research project with Prof. Puvi Reddy in South Africa, and we worked in the South Durban Industrial Basin, a region known for its dense co-location of heavy industries and residential areas with long-standing environmental and health concerns. And this study was initiated in response to complaints from local residents about dead fish, foul smells, and health problems after eating locally caught fish. So what we did was we sampled the fish and the water, and we worked in collaboration with the community. So while the scientific analysis was conducted by the researchers, the collection of fish and seawater was driven by the community. So it's kind of community engagement, but not really citizen science in the true sense. But these communities and the people who had these lived experience and who observed this kind of pollution provided the initial alarm. This collaboration reflects a classic example of citizen science where community members play a vital role in identifying environmental risk and triggering scientific investigations. So that was a study that I conducted, and although if anyone's interested, the findings of the study show that there was no real contamination or the health risk assessment showed no carcinogenic or non-carcinogenic health risks from consuming these fish. So in terms of a particular student, Hazel, that in our distance learning program, they as well, while not a citizen science in the strictest sense, one of our students conducted a project that shared many of the core values of citizen science. She investigated pesticide residues and potentially toxic element levels in a variety of rice samples in a particular region in Guyana. Her health risk assessment found that the rice was generally safe for human consumption, though it did highlight the need for monitoring programs, particularly for brown rice grains that was collected in the area. So although the data collection wasn't led by non-scientists, it was specifically done by the student, the success of the project depended on the active cooperation of farm owners and workers who helped the student. So this kind of collaboration between researchers and local stakeholders mirrors the spirit of citizen science by valuing community involvement, local knowledge, and shared responsibility in addressing public health and environmental concerns.
No, that's brilliant. Thank you. And it's great as well to hear how all of you have worked in sort of citizen science initiatives as well. So thank you so much for sharing your personal experience. So what I'm going to do is I can see that I've got a question from Alicia here in the chat, but it relates more to the course directly. So I'm going to move on to the course overview. And then what I will do is after the course overview, we'll come back to your question, Alicia, and go into it in a little bit more detail. So let me share my screen with you. So just to give you a little bit more detail about our analytical chemistry and measurement science programme. So there are a number of different study options which are available to our students. So you've got all of it is part-time and online, and all of the learning is fully online as well, just to make sure that that's perfectly clear for everyone. There's a few different qualification options, which is a master's, an MSc, or a postgraduate diploma, postgraduate certificate, or the CPD or continuing professional development. And the course is designed to fit around your professional and personal commitments. And the way that we do that is by releasing all of those learning materials online. And so you will study one unit at a time, and that gives you that time to fully focus on that unit. And a lot of the learning material is, well, it's all accessed online. So you can pick that up at times that are convenient to you. And that means that it is suitable for people no matter where you are located in the world. You don't just have to be based here in the UK. And hopefully you got that sense from our panel today as well. And because we are a global cohort and a global course, it also gives you the opportunity to build that global network of like-minded analytical scientists. So, on the course itself, there are a number of different units that you will cover, which are taught units, starting with the fundamentals of analytical science and then looking at a variety of different specialisms as well. So you can see, depending on which qualification option you choose, will depend which units are mandatory and which ones are optional for you. I'm not going to sort of read each one out because hopefully that's clear on the screen. But if you do want to discuss kind of individual units or individual topics, I'd encourage you to get in touch with us after today's webinar. So after completing the taught units, if you have opted to take the masters, then there is also a research project at the end, and that is where you will get to look at an area that is of particular interest to you personally or professionally, and really study that in a lot more depth with the support from academics here at the University of Manchester. And if you're studying your research project with your employer as well, then that will be through support for them. There are also two further research project options, which is a computational or theoretical project, or there is also the option to come to us here in Manchester to study your research project, which I know that Andrea has just briefly mentioned as well, that she'd come here to do that as well as part of her study. So one of the things that we do get asked quite a lot is how online learning works. So as I mentioned earlier, there is the option to basically learn one unit at a time. And you tend to do this over 10 weeks. So you have 10 weeks to study the unit, 10 weeks to work through the learning materials. And online, we break that down into kind of weekly, where we'd expect you to be up to. But you can sort of go ahead if you've got more time one week, or catch up a little bit the week after. But those weekly guides are there basically to keep you on track to be able to complete your coursework on time for the end of the unit. It's all coursework-based assessments, which I know a lot of people are always relieved to hear. And you learn through a variety of reading, instructional video lectures, live and pre-recorded presentations, video demonstrations, but also live tutorials. And because we are a global cohort, we know that sometimes that can be quite challenging to attend a tutorial live. So those are recorded, and there's always a way to catch up on that learning material if you're not available at that particular time. Although we do encourage you to attend if you can. And you get the opportunity through the online learning to apply your learning through things like simulations, interpretations, and computational training. And that is aligned to what is most appropriate depending on which unit you're studying at the time. So if you're interested in studying the course, to clarify the entry requirements, we require a first or second class honours degree or the overseas equivalent in chemistry or a course with a major analytical component. So that could be something like biochemistry, for example, where it's a bit more focused on biology, but it still has that major analytical component as part of it. Students who have other relevant backgrounds, such as significant industrial or research experience, can be considered at the discretion of the course director. And if English is your second language, then there is also an English test that we would require you to take, and you would need to score the equivalent of 6.5 in the IELTS, with a minimum of 6.5 in writing, and no less than 6 in all other subsections, or the equivalent. And we do accept a variety of different English tests as well, so it doesn't just have to be an IELTS test. If you don't have an English test already in place as well, you don't need it prior to applying for the course, and we at the University of Manchester can help arrange that English test for you if you do need it. And applications are open now for September 2025, and the link is on the screen. I will also put this in the chat once I have gone through the presentation, if you do decide you want to make an application to the programme. So in terms of fees and funding, you will see that the fees are broken down depending on which level of study you opt for. So if you opt to study one unit for the continuing professional development, then that is, if you're a UK student, that is £1,555 or £1,833. And basically it's worked out per the number of credits that you study, and going right up to the full price for the Masters, which is £14,000 for UK students, or for £16,500 for international students. If you choose to study your research project with your employer, then there's no additional cost for the research project. If you opt for the practical project at the University of Manchester, it's £3,000 plus fees, or if you wanted to do a theoretical or computational project, it's an extra £1,000. And there are a number of discounts available for the course. The one that's probably going to be relevant to most people, which I will highlight, is that we do have an application discount of 10% available when you apply by the 30th of June 2025. And if you are alumni of the University of Manchester as well, then there is an alumni discount available too. And if you want to discuss that in more detail, then I'll make my contact details available at the end. So that is a very brief overview of the course, but I will also share all of these contact details into the chat. And we'll also now come to Alicia's question as well, which I'm going to ask Rashila to come back on and to answer for us. Hi, Rashila. So Alicia's just asked for a little bit more information about whether there's videos available on how to use the analytical instruments throughout the course, or the different elements of self-study and how that works on the programme.
So, as you've stated, Hazel, because you have covered this in your presentation, the videos are available while you're studying the course for the 2 years. And I don't know thereafter, Hazel, whether, well, students won't have access to the VLE, so then the videos would not be available thereafter. But the videos are not downloadable, unfortunately, but all other learning materials are downloadable, materials that you need for your assessments and so on. So I don't know if that answers the question, but maybe Brandon and Andrea, who have been part of the course, can maybe they can reassure you.
Yeah, so as far as like actually how to use the instruments, I don't think that the course necessarily tells you, because there's so many different vendors and different instruments in general. But as far as understanding the basics of what is constructing that actual instrument, yes, I think it does a pretty good job of breaking it down, saying like for like mass spec or something, it gives you the components that you're expecting in a mass spec. So it will be very detailed, but it's not actually how to use them specifically.
Okay, that's brilliant. So that was the question that we've had submitted from our audience today. So we'll just give everyone just a quick moment to, in case anyone else thinks of another questions, to submit their additional questions. But other than that, I did just want to take the time to say a really big thank you to everyone for taking the time to attend today's webinar. It's been great to see so many of you here, and it's been really, really great to get your insight, Rashila, Andrea, and Brandolin. So thank you so much for sharing that with us today. I've just reshared the final slide with those contact details as well, if anybody does want to make a note to get in touch at a later date. And you will see that I've launched a poll just if you do want to indicate that you want to have a conversation after today's webinar.